Okay, hi guys. So this brings us to the last lecture of uh, the lecture series on JEE Organic Chemistry lectures. Okay, so this would be our last lecture that would actually complete our whole JEE syllabus. So let's get started. So the first we'll be checking the test for alkenes and alkynes. Okay, so first test we are applying is ammonium AgNO3. Then we have CO2Cl2. Then we are applying sodium metal test, or rather S2 gas liberation takes place here as a checker, and then we are passing it cold KMnO4. Okay, so let's see whether this compound, or let's see whether how many tests this alkyne gives. This is a terminal alkyne, so will it give ammonium AgNO3? Yes, we'll have CS3C, or rather directly write 2C here and C minus Ag plus. Okay, then will it give CO2Cl2 test? Yes, hydrogen gas would be released, cold KMnO4 would be there, and let's have another parameter, which is Br2, or bromination would take place or not. Bromination would take place. Would the bromination take place here? So for Br2 to take place, if we are using Br2 in presence of CCl4, then it would not take place. Okay, then next we see a non-terminal alkyne. Okay, so for this is not non-terminal alkyne, so ammonium AgNO3 will not take place. For CO2Cl2, I hope you remember that the red precipitation forms in case of only terminal alkynes. Okay, we'll write the reaction. If you are not able to get it, we'll write in subsequent seconds. So with NMetal, it will also not take place. Cold KMnO4, it will take place, because KMnO4 just looks for double bond or triple bond. With Br2 also it will not take place. Or so if we actually remove Br2 in CCl4, and rather, or we can even take Br2 in presence of water, then let's say the reaction will not take place as fast as it would have taken place in case of alkenes, but still we'll say that okay, the reaction will take place, obviously at a very slow rate, but it will take place. Okay, why? Because of formation of our highly unstable vinyl radical. The reaction will take too long to proceed, but it will give some product in the end. So based on that only we are having a tick mark as of now. And what about this compound, alkene? For alkene, again AgNO3 test will not take place, because it's only for terminal alkynes. Again CO2Cl2 will not take place. Sodium metal test will not take place. Br2 will take place, and KMnO4 will take place. Cold KMnO4 just attaches OH as a syn addition on a alkene or alkyne. Okay, so now let us see the case wherein terminal alkyne is subjected to reaction with AgNO3 and other reagents, CO2Cl2, etc. So if we have ammonium AgNO3, so we'll get something like this as the product, C minus Ag plus, white precipitate will form. Okay, what about this compound? When we reacted with CO2Cl2, then we'll get something like this product, which is red PPT. Okay, if we pass it in sodium metal, then we'll get something like C minus Na plus. Okay, and half mole of H2 released. If we reacted with Br2 water, Obviously rate would be slow, but it will still happen. Rate would not be as comparable to alkene, but it will still take place. Again with cold alkaline KMnO4, or cold rather dilute KMnO4, the OH will take place, the addition of 2 OH will take place. Okay, so now comes the last part of our JEE syllabus, that please note that HBr undergoes, or rather only and only HBr undergoes peroxide or anti-Markovnikov rule. Okay, so what is anti-Markovnikov rule? I hope you remember the mechanism in which free radical anti-Markovnikov rule take place via addition via free radical as in the RDS. Okay, so this is the first step I am just writing. So this will actually convert itself first into, obviously there is a double bond between here. Okay, so this free radical will be attacking on this. As a result, we'll be getting free radical here and CH2X formed here. Okay, so this was the first step. Okay, and the next step would be obviously on this free radical it will be attacking on HX. This bond would be cleaved and H dot would be attached on this free radical. So as a result, we'll be getting this as the compound. Okay, so we are now comparing delta H of the two reactions, and let's say X was, in this case X was rather HX be something like HF, HCl, HBr or HI. Okay, so what happens on delta H? So delta H for this step is obviously negative. Why it's negative? Because F minus would be less stable as a free radical than a attached form. Okay, similarly till Br it would be negative only, but only I would prefer to rather be on a I dot because it is stable more as a I minus. So same can be said for I dot as it is identical with I minus. So delta H for this case when X is I would be positive. Okay, then next, what about this reaction when HX bond is cleaved to form X? So to form bond with H and X, sorry, this free radical and H and plus X dot is again degenerated in the reaction. So in this case X dot is less stable till Br. Okay, so this would be positive, this would be positive, this would be negative, and this would be negative as well. Okay, so as in case, as you can see that here HX bond is getting cleaved and X dot is getting formed, hence HF HCl already have a strong bond with hydrogen atom, hence delta H for them would be positive. Okay, and for HBr this is experimentally determined fact that delta H for this is negative. Okay, because Br dot is seemed to have, obviously Br dot would be more stable than HBr bond. Okay, as we have seen that down the group, as we go down in a group, as we go down, the stability of I minus or I dot, Br minus or Br dot, Cl minus or Cl dot, F minus or F dot increases. This is the stability order down the group. Okay, and obviously the reverse would be the stability of order of bond with hydrogen. Okay, so just remember these two orders of stability. Hence in this case HF would be more stable than F dot, and HCl would be more stable than Cl dot, and beg your pardon for that. And similarly HBr, since HBr and Br dot would be more stable than HBr. Okay, so the delta H for Br is negative, and obviously for I dot would also be negative because I dot would be highly stable than Hi. Hence this is the delta H for the two steps. Hence we can see that for both the steps delta H is negative only for HBr. Hence this reaction only takes place with HBr. So the anti-Markovnikov rule, or the peroxide, for the peroxide reaction only the HBr undergoes the mechanism. Okay, so this is the reason behind it. Okay, so with this we come to the end of this course, and we have successfully completed our JEE syllabus for organic chemistry. I hope you enjoyed both the series of lectures, and wish you all the best for the coming year's JEE examination. Okay, so with this, good luck and goodbye.